वो stuff. ठीक है एक मिनट. चलेगा. ठीक है ठीक है. अ, अ, चल रहा है ना स्ट्रीम शॉनिश. चलो है ना हाँ ठीक है ओके ओके so welcome Amishi, welcome Nisarg to our paradigm hackathon. So our hackathon started yesterday at 6 p.m. and after 16 hours of um, after 16 hours of the hackathon, we finally have our top five teams. So the top five teams have been shortlisted after the judging criteria that we posted on the website itself. And we got registrations from different colleges across India, and we got around to 350 plus 100 plus registrations and 50 plus teams in the competition. And out of those, 26 teams participated and submitted their submissions, and from that we now have our five teams. So first of all, thank you so much for coming to judge the for the final round. I really appreciate that. And and you both have been part of CodeBase. I guess since the inception of CodeBase, you both have been part of it. You have seen this club grow, and when I got the responsibilities of handling the club last year and forming a team and restructuring the identity and everything. So from that low point to now impacting over now through our initiatives, through our coding competitions, hackathons, workshops, we impacted over 400 plus students in both in the campus and through online events as well. So it wouldn't have been possible if you guys weren't there to start this club at first place. So thank you so much. And
Thank you for having us, and it's great to see you guys carry forward the legacy and build up and build on top of what we've worked on. So yeah, it's just cool to see you guys do so much and achieve so much.
Yes, I totally agree with Nisarg. Over the last years, you guys have done splendid job. Like what started as a small bootstrap idea between like four people last year has grown so well, and I'm so excited to be a part of Paradigm and really looking forward for the presentations which will be coming up.
okay. So Vivek will explain the problem statement again, just to and also the whole process that we went through to filter out the five teams.
Hi, I'm Victor. I'm tech head of this Going Club. So the problem statement, I will share the screen. So basically, we thought of giving this problem statement title known as social life and on autopilot. So really coming to see like why did we choose this problem statement? So for the particular background, like we are always connected for like between academics, internships, side projects, and social life. And like the thing which we always suffer in, which is like relationships. So there are like various things which we suffer in, like delayed replies, forgotten follow-ups, long periods of inactivity, which we also call as ghosting, and buried plans. So the issue is not always the communication access. It is also like some sort of absence in intelligent automation around it. So the challenge which we thought of giving to the participants is to build an AI-driven system that automates relationship and intelligence using communication data. So the solution was just to transform the raw interaction logs into a structured insight and automate those into social actions by reducing some cognitive loads for maintaining relationships around many sort of people. So we told them, like, we gave some clue to the participants, like for to export some chat logs or to use some synthetic data sets if provided, and email or interaction history of data. So the goal around this was to design an intelligent system which detects patterns, decisions, and triggers meaningful actions. Since this program statement is around domain AI for automation. So what did we expect from the participants? We expect them to design and implement a AI-powered automation pipeline, which is not just a chatbot or a single LLM call. The solution which we expect from them is to analyze communication behavior over time, to demonstrate structured system design, to basically make intelligent decisions based on those patterns, to identify patterns or anomalies in interaction, and to automate meaningful outputs, like, for example, suggestions, prioritizations, reminders, insights. And we basically encouraged him to innovate in various, like, in scoring mechanisms and for decision logic, state management, via feedback incorporation, etc. So this was the promise statement. Thank you.
Yeah, I'm just contacting with them. The first team is ready, so I will just send him the link. And I guess I'm sending the schedule to you just in a second. I will let you know. Just a second. Just a second. Okay, so the first team that is coming for the presentation is Cluster Coder. He will be joining shortly. Also, please, Amishi and Nisar, please just I've sent the poster of the top five teams in the group. Just have a look at it.
Yeah, we'll go through it. So are we following this pattern or are we not following this
Uh,
pattern?
I guess some of the team, like a team or two, has requested for a little, like for 5-10 minutes. So I'm
Yeah,
for
yeah,
right.
no issues.
Yeah. So the first team that is coming for the presentation is cluster coder. We are
All
starting
right.
with that.
Mhm.
Hello, am I audible? Should I start presenting? Okay. Does the presentation include the demonstration also? Oh, okay. That's fine. Should I start like sharing my screen? Uh, yeah, just 1 second. Is the screen visible? Okay. Hi, I am Mantek Singh Byrne, and this is Bubble One. It is basically social life on autopilot. It it is a privacy first autonomous relationship co-pilot that like detects when relationships are drifting and takes context aware actions to then preserve them. As we know, people don't lose friends on purpose. Connections silently decay over time because we get busy, lose context, or just forget. Therefore, we need a system for it. Existing reminders are static and they are also context blind. And therefore, ये and आपके जो smart assistants हैं, they require full chat access, which is not in line with cybersecurity. Therefore, this is the solution that I present. Bubble One only ingests metadata and the short abstractive summaries. It like never takes the raw chat. Also, just for your information, the diagrams were I was not able to insert them into the PPT, so I'll will show you the diagrams here. So, so Bubble One never takes the raw chat data, and it only computes using the summaries and the metadata. It computes an interpretable relationship health score. This is the UI. You can see the average health here. And it then detects the anomalies and it uses land graph and the RAG and also a recursive learning loop to then take the appropriate actions. What makes Bubble One different is the fact that it is a privacy first design. It has an explainable scoring math, yeah, which is not a black box. It also has land graph orchestration, and so therefore the LLM calls are auditable and they are controlled. And so for the demo, let's assume that you have 5 close contacts and you uh, want to like analyze the interactions, the frequency drops, and like and so you can then use Bubble One. It will uh, detect sharp score drops. It will also query the past context using the RAG. It will draft gentle check-ins, schedule your follow-ups, and it also logs the entire decision so that it is auditable. In the project, I have used a simple hash, but this is scalable to include a blockchain implementation in the future using something like Mistral. Um, in the architecture, the front end is React. Then we have the API का वो gateway, and also in the ML service, we have the fast API, the land graph, and the RAG score is made up of the SQLite and the Facebook cafes. And there is a small JSON system of record and a hash chain of all the actions that were taken. The API runs in the background. There is a background worker that implies a real-time decay. So this is completely automated, and you don't need to actively send the messages. The system will do it for you. It will also analyze how the relationships are changing over time. It will sweep the overdue items and also trigger the actions. And the privacy in the system is engineered so that we will strip the raw text data, and the data that is passed to the ML only has the hash and the metadata and the short summaries. And there are certain identifiers that we have also used. As you can see the formula here, it clamps the scores between 0 and 100, and they are then banded into good, fading, or critical. Positive interactions add impact, and then ignored or missed interactions accelerate the decay. Now, the land graph orchestration, uh, it orchestrates the decision nodes, and it analyzes the anomalies, and it also implements the contextual RAG retrieval, plans the action, and also schedules and executes the draft messages. Now we have also built guardrails, cooldowns, opt-in, auto-nudge tools. And so the system will learns, but it is also transparent and safe. Bubble one reduces cognitive load, rescues at-risk ties, and gives user confidence with explainable actions. It is practical today, and you can run it locally using Docker, Open API, and we also have implemented local fallbacks. Now, I will show you a short demo. So I am going to seed some synthetic metadata, not the raw messages. And the starting worker will compute the scores and will run the automation loop. So once I have run this, you can see that the synthetic metadata has been added here. Now, yeah. So it would drafts the messages for you. So this draft was generated by the ML planner after the RAG looked up the recent summaries. This text is short, empathetic, and it is also context aware. It is not a canned template. I can yeah, I'll just show egg or cheese. So here you can work, where you can see that all the actions are hashed, and there is no record of the raw text data. Also, this happens in real life context, and you can see that the anomaly has shown up here, and I can draft it, send a message, or I can enable auto nudge, which means that the system will automatically respond over time and deal with the replies and everything. You can see the tracked contacts, average health, and the live tracking counter here. So I am open for questions now.
Yeah, firstly, really good presentation. I have a couple of questions. Starting with,
Hanji,
you mentioned that it uses metadata and summaries, right? Uh,
yeah.
So where do these summaries like come from? Are they inputted by the user, or like how does your application get the summaries?
Okay, summaries are generated at the ingestion time using an LLM. So इसमें मैंने Open API का वो की यूज किया है. ये I have वो used ये वो ChatGPT का 5.1 वो codex वो the model, and we never वो store the raw messages. We process them in memory, and it then generates a short abstractive वो summary, and जो original जो text था, that is वो discarded. जो memory में जो वो रहता है is only the summary, the आपका the embedding and the metadata.
Got it. So essentially, the creation of the summaries is done by the OpenAI
LLM.
LLMs, right?
Yeah.
Uh,
And then the original text is वो discarded. हम वो store नहीं वो करते हैं.
yeah. So your application does not store it, but whatever API calls you are making to say OpenAI, for example, will
Yes.
have all the raw message contents, right?
Yes,
So-
but with that is ये उसका कोई वो workaround है नहीं, since we need to use a LLM to वो draft the messages, because उसका जो वो दूसरा ये वो option है is to use predefined templates जो कि genuine वो feel नहीं होते हैं, सारे
Got it.
text same होंगे.
Yeah, makes sense.
Yeah.
Yeah, I think I just have one other question.
हाँ जी.
Yeah, so I mean, I can see that your approach is, quite privacy focused, or rather cyber security focused, right?
Yeah. So I am a cybersecurity student, so I think that is the outlook
Got it.
that I had.
So first of all, I really like the idea of those hash chains, and having that audit accountability.
हाँ जी.
I think that is a good approach even without the blockchain implementation. But
Yes.
I'm concerned about now every messaging app especially is moving towards more privacy friendly features like end-to-end encryption and all of that. So how would you tackle that situation wherein, if say for example tomorrow you're not able to read, you're not able to get the raw text to send to the LLM only?
Okay. So, if the messaging apps are not end-to-end encrypted, then yes, so well, if the apps are end-to-end encrypted, you we can't read the messages. So इसको tackle करने के लिए okay, so end-to-end encryption में the messages are protected in वो transit वो, right? But वो user के वो device पे the messages are unencrypted. So the messages can be processed locally on the user's वो device, and that would not वो break the encryption. So हमें in transit access की तो वो जरूरत है ही नहीं. ये वो we don't need server access to the messages. We can process them locally on the user का वो device जहाँ पे वो encrypted हैं, and the summaries can be generated in memory. Then we discard the raw text and वो metadata store वो करेंगे. तो end-to-end encryption I think still aligns with my privacy first architecture.
I see. Yeah. Amishi, do you have any questions?
Yeah, I just had one doubt. First of all, great presentation. I like the idea overall.
हाँ जी.
I like the idea that you said that it's a privacy first approach.
हाँ जी.
Okay, but thoda, can you emphasize more on that? And you can answer that and add one more. That you just mentioned, no, that it's storing while open API and everything. So how will you what will be the approach to deploy it locally, let's say?
Okay. Okay. So I am not building an AI that like who reads your chats. I am building a personal intelligence engine which like privately yeah like वो runs on your वो device. So like आपके so okay आपका जो like वो लोकल का आपका वो जो डाउट था तो उसके लिए हम ओपन एआई को एक लोकल एलएलएम से वो रिप्लेस लाइक कर सकते हैं लाइक आपका ओलामा वो आता है नाउ द समरीज आर लाइक जनरेटेड वो लोकली द ड्राफ्ट्स आर लाइक जनरेटेड वो लोकली एपीआई कीज वो यूज नहीं वो हो रही हैं वो लाइक क्लाउड भी वो यूज नहीं हो रहा है तो आपके टेक्स्ट लाइक कहीं वो जा ही नहीं रहे हैं सो आई थिंक दैट इज लाइक ये लाइक वो वन ऑप्शन एंड इन दिस हमारा जो लाइक वो डेमो है आई हैव लाइक वो यूज्ड वो डॉकर टू लाइक वो स्पिन अप अ लोकल एपीआई द एमएल वो सर्विस द एसक्यूएल लाइक वो डेटाबेस वो लाइक वो फॉर द रैग एंड इसमें भी द समरीज आर लाइक जनरेटेड using like आपका वो open API but I can वो replace this with something like Olama so that no data ever leaves the machine. So in a way cloud deployment जो like open ये API का वो use है it is optional locally भी like कर सकते हैं also इसमें एक local implementation by default है तो like मेरा initially open API like वो लाइक कुछ चल नहीं रहा था क्योंकि उस पे वो क्रेडिट्स लाइक थे नहीं तो लाइक एज अ बैकअप आई हैड इम्प्लीमेंटेड अ टेम्पलेट के लाइक इन केस द की डज नॉट वो वर्क इट विल वो यूज द डिफॉल्ट लाइक वो टेम्पलेट को लाइक वो सेंड द मैसेज
Okay, understood. Got it, yeah.
हाँ जी एनी मोर वो क्वेश्चंस
No, I think we are done from our side.
ओके
Thank you.
सो शुड आई वो लीव
Yeah, sure.
ओके
We will let you
थैंक
know.
यू थैंक यू सो मच बाय
Thank you.
Thank you.
Okay, so the next team that is coming to present is Orion. Can you just add him in the team?
Hi, hello, good afternoon, everyone. Myself Will Saxena. I'm from Team Orion. I'm really sorry. My partner, Shristi Varule, she is actually in Mukesh Patel School of Technology, and she is like right now having that table tennis, uh, table tennis finals right now. So that's why she was not able to come. I'm really sorry for that. And
That's
I-
all. Yeah.
No issues.
so yeah, so yeah, let's begin with it. Yes. Yeah. Yes, we are. Oh, yes. So, yeah, let's go. Yeah. Okay. So, basically, let's begin with the. Okay. So let's begin with the what. Okay. So what we have created is what we have actually. Oh shit! 1 second. I'm sorry. Hey, is it visible now? Yeah. Is my screen? Is my yeah.
Yeah, that's it.
Yeah. So basically, yeah. So for this topic, we have actually created something which can actually be like used in used in real life because this is a really great topic and actually it's very much required nowadays because what happens is that even though we are having a lot of conversations like a lot of conversation with a lot of people, what really happens is that people not necessarily get bored, but they are not able to uh, handle some relationships or they are not able to focus on some things and because they get distracted or because they're not able to focus on it, it basically withers away and it basically just goes away and it decays. So the relationship decays. So we have built a complete product which can actually be used in real life. We have created this AI agentic model using line graph. So it is not a normal LLM call. So first of all, in this, like the way the data is ingested, if there's no dummy data inside of it, I have actually it has okay, let's do the process while we are at it. Release. I actually have the account logged in also, but it's not show for signing in. So yeah, the username has already been taken. So basically, this is what the dashboard looks like. That was the home page. What are the things which are present inside of it? It's not just a UI; it's actually backend heavy, more so. So basically, what can happen is that it can take a chat as an input, and we are in this hackathon we are trying to like automate the whole process. So we went as far as to automate everything which we can. So we have used Puppeteer and headless browser from Microsoft as well, in or headless browser also, but in this one we have used like the normal browser so that it is also visible. So what happens is the data can be ingested using three things. So if we look at analyze chat, and it will automatically fetch the relationship. So if we are adding a particular person and then another person, then it will be able to catch like whatever the whole thing is, like who that person is and what are the points, or basically what are the synthesis, what is the analysis which has been given. So for input, we have this for this WhatsApp text can be in WhatsApp chats can be exported. So if we look at it, like if this is a chat, if I want to, like if this is a chat with my friend, and if I I exported it, and if I upload it, what is going to happen is basically that, yeah, it is basically going to analyze it, and it is going to give me a score, and it is going to give me all these ratios. Now all these ratios have been completely like researched, and it's really paramount, and it's important that we understand this, that basically for this point scoring, what happens is that many people use LLMs for these point scoring, but we have used this 8-layer we have used these 8 layers. Vader NLP sentiment. So basically in Vader, like in dictionary, like there is positive or some positive words, some positive or some negative words. So that is what it calculates. Now all these layers in this first section of this 8 layers, all of these are very, very deterministic. Why so? Because for the same input, it won't make sense if there is a different output. And for LLMs, as far as it goes, until and unless the temperature is 0, it can give different outputs. So all of these will be calculated and will be combined, and then a score will be calculated depending upon, yeah, it can, I mean, we have also seen, like you can also see it here, but all of these what is going to happen is that all of these will be calculated, and all of these will be calculated, and score will be given out of 100, and that will be used furthermore by the AI agents, and which are going to do perform some actions. Like there is a conflict resolving, decay, stable, and style analyzer and ghostwriter, depending upon what the situation is. So if the situation is that there has been some heat going on lately, so for analyzing that, there is a different function, or there is a different agent, or for if there is a conflict for that, then this is different. And for ghostwriter also, basically it can do a lot of stuff. So let's do this one. So if I am actually, like, this one is cool, so let's connect WhatsApp. So if we connect our WhatsApp using it, then it is yeah, what it should basically do is that it should automatically, I created I made it in the video as well, that what it should basically do is that wait a second, why is it not working? I'm really sorry, wait, it is totally working, and it actually opens the, yeah. So basically what happens is that it
Also good.
yeah, I'm really sorry for that one. It is actually a fully working prototype, and what it does is that, yeah. So
like,
on this portion we can see, yeah. So from here,
might be
so when we this was I made this video, and right now
the automation part is like
there is an issue with the backend, that's why it's not working. But as soon as we will click on that, as soon as we will click on that connect WhatsApp, it is automatically going to open a Chrome window
browser. It will automatically open a browser just for this
and
purpose we are using.
yeah, they don't have to do anything of that. Already one window is open, it opened another one, and then what they can do is that it will be a link. So the WhatsApp is linked. Now what they can do is that I told you that for inputting we have different options. We can even input text message from WhatsApp or JSON message from Instagram or MP3 from audio, or in this live section you can just type the name of that person. Suppose if I type name of my friend, then I can just type the name of that person. It will automatically go to that headless browser, but in this one we can see it actually. It will automatically go to the headless browser, type that person's name inside of that browser in the WhatsApp section. On the WhatsApp, it's automatically and then it will automatically go up and down. It was necessary because when it goes up, it actually forgets what was the comments below. So DOM actually takes in the output for that. It needs to go up and down, and after that it will fetch 50 conversations, last 50 conversations, and it will create that score, and it will pass through the it will pass it through that 8 layers, and after calculating it will automatically call whatever the agent which is required to send. So in this AI drafted messages, we can see like yeah. So basically, in this auto send option also, we can literally just click on this auto send, and it is going to form these messages. And even there is a big story behind these these messages are not just any messages. Basically, it will sound very robotic. Like we talk with different people in different ways. I might talk with my friend in a different way, basically in a different tone or in a different way in general. So it should actually understand, and for that we have used Pinecone and Chroma DB to store it, so that it is able to semantically it is able to fetch it better if we rather than storing it in Postgres like SQL. So when we click on this auto send, it is automatically so it is automatically going to open WhatsApp, and it is automatically going to type that inside. You just have to send it. Like it is automatically going to do that
inside the text box. You just need to send it. It is automatic.
Yeah, and it can do this. It can do this for every like person. Like you can basically, you don't have to do anything in this browser. It is just for showing. You can click on that link again. If the WhatsApp is linked, it's gone, and the session will remain. You can click just click on the different person. Like if I click on my different friend, automatically. Yeah, so it is going to add that person as well automatically.
It is automatically.
Yeah, it is automatically going to do that. So basically that is what we have created, and yeah.
Okay. First of all, it's a very good prototype. I love the fact that you have like tried to. It's a 16-hour hackathon, and you have tried to accommodate as much as possible. Great job on the website and everything.
Thank you.
Although I did have like one question, which was key. I understood that there are like 8 scoring output layers, like some 8 layers, right?
Yeah.
So how is the final health score being calculated? Like, are you using some weighted or like heuristic based?
there is weightage. Like there is like we calculate like a decay. Like we calculate
Okay.
decay and heat. So if in the conversation it can sense, like using the Vader sentiment, it can sense. It is going to calculate the Gottman score. Basically, the Gottman score, it is scientifically proven that in a healthy relationship it should be 5:1. So 5 negative, 5 positive, and 1 negative. If it is more than that, then it's a good relationship. It's going good. If it is less than that, then it is it is going to say that there is some decay, and it is going to trigger an AI agent. But how this score, this is the health score which we say, as in how it's calculated, if that is a mathematical formula, simple one. And yeah, so basically this one. So heat and decay is calculated, heat by decay is calculated using like these are the weightages, like 15% Vader, 15% frequency. Like what is the frequency of messages which one person is doing? Or this Gemini LLM is not actually a black box. This is we are calling this using temperature 0. So it is always going to be deterministic answer. So that will give different outcomes for the same input. And the effort is basically what are the length of these messages. And mirroring is basically how much reciprocity is there. And the scale drift is basically an average of everything, like the difference between the time plus the average of the length of these messages calculated. And according to that average, how different is the last 10 conversation it is calculated. And that is what scale drift is. And all of this is calculated. Combined heat and decay is calculated. And based on that, AI agents are called.
Okay, cool. Nisar?
Yeah, even I have a couple of questions. Firstly, good job in presenting the entire software in such a short time. Just right now, you mentioned you are using the Gemini API, right? I'm assuming it's an API.
Yeah. So
okay. So my question is, what if you remove that layer? Like, how will your actual reasoning be affected?
Yeah. So actually, what was happening is that Vader is going to give a score between -1 to 1, depending upon how positive a word is. Like a word like a good is a positive word, or bad is a bad word. So that gives a score between -1 and 1. It has already been established. But this one is 100% deterministic. It is very simple mathematically, and it is always going to give deterministic output. But in certain scenarios, all of these things are never going to understand the emotions. Like LLM can take in some input, and it can tell how what are the sentiments. Are the sentiments positive? Are the sentiments negative? Or is there distant emotion? Are there some is it rage, or is it something like that? Basically, it can tell emotions at a certain level, which all these deterministic modules can't do. So that is why we are calling the Gemini API, but we are calling it with temperature 0. So it can either give a structured output, like the person is who is more dominant, if the emotions are going in the right direction or not, or are the emotions positive or are the emotions negative. So in a broader way, it will be able to better understand the emotions and give an output, but just so that the scores are not affected. So basically, we are having only two classes. Either it is 0 or 1 for all of these things. Either the person, if the conversation can be positive or negative, 0 and 1. So temperature is always 0. It is never going to give it is never going to give a basically on a
Uncertain
scale,
answer.
on a scale. So never going to give an uncertain answer. So all these 8 layers combined are always going to give a perfect same output for the same input, so that it's actually deterministic. So that's why
Got
LLM
it.
has been for like for behavior.
So basically, you're using an LLM to make your results more human friendly, or like
Yeah.
normal, like actual texting language friendly, right?
Yes,
So I
absolutely.
think removing that, it would affect your result a lot, right? Like if
No,
you just
removing that, the Gemini LLM, or basically any LLM, we can even run it locally. I ran it locally on Olama.
okay.
We have given it like 20% weightage on it, but it is only giving a positive sentiment or negative sentiment kind of like
Uh,
output.
yeah,
And
I
even if
got
you
that. So
remove,
basically, your solution is compatible even with local LLMs, right? Like
yeah,
that's what I was getting.
it is compatible with local LLMs.
Cool.
I even installed like I had like three LLMs running, two LLMs running on it. So basically, even a Llama 8 billion parameter is going to give right answers, and it is very like it is very friendly. It can run like in 4
Got it.
gigabytes of RAM, so it is very friendly. And even that is also not necessary if need not be. Like
Got it. Got it. Yeah.
it is totally possible for us to like not use it and totally remove it in this scoring section. But in agentic, when the agentic AI is called, in that case, the reasoning part of that whole agentic loop. Yeah, sorry. So for that, like we have like used LLM, but we can remove it or we can run it locally as well.
Yeah. Sounds good.
Yeah,
Uh,
and yeah, sorry, and we have this like WhatsApp automation, so we can. And also, there is a Telegram bot also which we have included. We are going to use Clawbot, but because of security issues, we didn't use Clawbot.
yeah. Sounds good. Thank you so much, Viral, and all the best.
Thank you, Bea. Thank you, ma'am. Thank you, everyone. Thank you for organizing. It was a really great experience, and yeah, part again. Thank you.
Thank you.
Thank you.
I will get back to you with the feedback. Right now we are running out of time.
Yes, sorry. Thank you.
Yeah, that's all.
Thank you.
Thank you.
Thank you. I
Yeah.
can leave
Okay.
the.
Yeah, just leave the meeting.
Thank you.
Okay, so we have two teams done. Next team is bits to bytes. Sean is just add him into the heat. I guess it's group of 2 or 3 people.
Oh yeah, yeah.
Yeah. So okay. So for since you're the for since you are the group, so just like the team leader, you will speak and present the whole presentation, and
Okay.
others can answer the questions, the follow-up questions after once the presentation ends.
Okay, so basically, after I finish presenting, everyone else can take part, right?
Yeah, just like yeah. So you will get 7 minutes for the presentation, and the demonstration. So after that 7 minute ends, everyone can answer the anyone can answer the follow up question asked by our judges.
Okay, all right. Can I just ask someone of my team members to present? I can just speak. Is that fine?
Yeah, sure.
Okay. Yeah.
Yeah, I'll present for you.
Yeah. Can you present?
Yeah.
Can you just let me know when the timer starts? All right. Perfect. Thank you.
Yeah, just give me a second.
Yeah. Sure.
Yeah. Is it visible?
Just. Yeah. I can see.
All right.
All right. Yeah. Good morning, respected judges. We are team Bits to Bytes, and this is our solution, which is Social Pulse. It is going to be the heartbeat of your relationships. Yeah. Can you go to the next slide? So we try to understand what the essential problem is throughout this entire hackathon, which we found out is that nowadays in real life, we're just measuring relationships on surface level. Like we just look at the number of messages somebody's sending. If suppose you're chatting to a best friend, then you'll have an X number of messages, but we never look into what the messages mean. We never look into who starts the messages, who initiates the messages, and what the tone is. Also, emotional drift is going unnoticed. People are busy in their daily lives nowadays, and conversations gradually become shorter and colder because if nobody has time, and then they require a lot of their time to actually give and then actually realize someone's problem. A core insight which we found is that messages which we send, they are not just messages, they are patterns and behavioral signals. Every chat has hidden patterns where we can identify effort, emotional tone, also planning intent. Relationships can be measured structurally as well. Through our entire AI generated system, we have enhanced it by using scores which measure relationship health, imbalance of emotions, and also calculating friction and drift scores. Our analogy and main understanding is that we are the sun and we are the center of the galaxy, and whatever we do is the around whatever we do, everyone revolves around us and our engagement and energy. Furthermore, our solar system model is to show how relationships orbit around the sun and how everyone orbits around you the way you treat them. Yeah. So our solution, Social Pulse, is a very simple solution where it's a very easy user-friendly solution where the user just has to upload the CSV file of his chat with only 3 columns, which is the timestamp, the sender, and the message. Then our AI-generated system classifies it as a group chat or as a single chat. If after identifying which type of chat it is, the one-on-one chats have different features for their scoring and also for their presentation. And also group chats have many additional features which basically articulates which person in the group participates actively, if one person dominates the entire conversation, also if whether the entire group activity is declining or going ahead. We also have a relationship state model, which the AI identifies, and if effort is one-sided, it detects that and lets us know. We also have an intelligent actions engine, which is a relationship needs attention, which the AI has to tell the user if the relationship needs attention, if emotional imbalance exists, and then all of this is relayed to our backend, and then it's stored in our database, and then the machine learning model which we have built, it predicts all the emotions and tracks it, and then displays it on our front end for the user. Yeah. So the one of the most key features is the one-on-one chat, which is the most essential and I'd say the most used also. We detect the messages through time signals, effort signals, and emotion signals and intent signals. There are many formulas which we've also used to calculate the scores. Example, the frequency trend, which basically takes all the messages from the past 30 days and all the recent messages and compares them and removes a proper trend for it. Also, effort signals are done through initiation ratios, which basically understands and makes the user say okay, which person is initiating the conversation more, which person is replying, and what's the average length of the messages. Emotional signals are also one which is very tough to calculate, but we've tried to integrate very well, and it makes the user understand if the mood shifts over time, if some person is jolly before and if it's angry with him later. It makes it very easy for the user to understand and gives a proper data on that. The intent signals are also one important key feature which we have added, which also tracks important events. Like if somebody has forgotten to wish someone's birthday or wish them good luck for an exam, it makes them understand that and makes them realize that they have to reply to the so-and-so person. Our main USP, though, is still the group chat analysis. Many AI driven systems would have just focused on the one single chat user, but we have focused on an entire group chat as well. We can focus in a group chat on many people. There are some people who initiate the conversation, who dominate the conversation, and who are ever present in the conversation. While there are some people who are dormant throughout, and then they require attention from the others to show up at the perfect time. Then we will also have individual and group dynamics. If one person is more close to other person, if they chat to this person specifically, then we can get to know this through our group chat analysis. Relationship state metrics, relationship state, the relationship health, engagement strength, and momentum. Emotional debt also is calculated, also through our friction score. Yeah. So the way we entirely built this entire architecture was through just by uploading one CSV file. And now I'll try to explain how we made the system. So the first, the user, we for entering the CSV data, we use Papa Pass, which was used for parsing and data extraction, and also for making the machine learning model learn about the messages if they're given in slang terms or also if they're given proper machine language. React content is also used where we use the where we use React front end to make HTTP requests to the backend. We also use TypeScript for the front end. The main natural language processing and feature engine was the entire crux of our problem, where we use tokenization and Unicode emoji detection for phrasing a proper context of a paragraph and making the user understand what the other person is actually trying to say and what the response has to be generated as. We also use many behavioral patterns and analysis through the scores, which where we also use spacey dependency parsing, which has been used, and also radar sentiment scoring has been used for this same thing. Our backend layer is entirely based on Node and Express.js, while also we've used where we use REST APIs to connect the backend and the front end and through the database. Our machine learning model is entirely based on XGBoost Health. It calculates the friction score, the risk, the random forest, and behavioral grouping engagement. Structured behavioral features, segmentation. Yeah, sure. Yeah. So it also calculates the behavioral features through that. Yeah. So
Do you guys have a demo of
yeah,
the
so
product?
I think the next slide is the demo.
Yes, I'm presenting the screen.
Yeah. So here is the first login user page where we can see the user has to simply just log in, and if they don't have an account, they can create an account. After logging in, the user can see that they have to just upload a CSV file, and then we can, through our metrics and our machine learning model, can see what data is being generated. So as we here have uploaded the file, here we uploaded a group file as well, where you can see the group dynamics of the system. Here the sun is the center, which is the user, us, ourselves, and all the planets in its proximity are basically trying to say which if this planet is smaller and red, that means you have to give more attention to this relationship, while the other planets are also doing well. On the other tab, we can see all the relationship scores for each and every person. Also in the group chat, we can see which person is initiating more, your initiation share, and emoji only replies as well, and a positive sentiment as well. So here we can see all the members of the group chat as well, which can identify which person is more active and which person is more dominant. Yeah. We'd like to integrate Social Pulse into most of the systems, and I hope you liked our presentation.
Yeah, great presentation, guys. Good concept. There's still like a couple of questions that
Yeah, sure.
like I have. So first, I was like, the problem statement is about automating the processes, right? From what I can understand, you are uploading a base file into the model, and then the model is doing all the processes
Yeah.
later on.
Definitely.
But if how is it automation? Because the user has to upload the files again and again, right? So won't that be an effort?
I'd like to speak, Shlok.
Yeah,
Sorry,
yeah.
Shlok.
Yeah, sure. No problem.
The main issue which comes along with building a text bot which tracks the messages are the privacy issues. Privacy makes as a key problem right now. So we decided to first take the user permission, and user only selects if he wants to upload the file. So if the user is uploading the CSV file, then the user is giving us the acceptance to use his data. And if we built a chatbot, it will be very difficult for the
It'll be
user
very tedious for
as
the
his
user.
privacy will be breached.
Yeah.
Also,
Okay.
adding on to Kavya's
Mhm.
point, what we really thought is that not all of our relationships really need analysis. Like, a lot of our lives also revolve around normal, mediocre conversations which we don't need to analyze. So, that additional work is really redundant, and we'd like to focus on just like certain people that really need that extra attention.
Okay. Can you, if it's possible, can you show the file that you are uploading? What is there in the
Yeah,
base file
definitely.
that is being
Kavya just
uploaded?
presented, right?
Yes, ma'am. Just a second.
So we try to shorten the amount of columns which we had. Like these three columns are essential, which is the timing, the sender, and what message is being sent.
This is a CSV file, ma'am.
Okay.
The timestamp has been hashed.
And how are you creating the CSV file? Like if I'm a user and I want to upload, so
Yeah.
what to do?
So basically, if your chat is on WhatsApp, there's always that option on every text messenger saying extract chat,
Yeah.
and that's how you get the CS.
Yeah.
Yeah.
Okay.
And
You
that's
said.
not just for, I think, personal chats, that's for group chats as well. So you can upload them either way you want.
Yeah. Okay.
So this CSV, whatever you just shared right now,
Yeah.
that is the one that is uploaded to your portal, right?
Yeah. Correct.
And that
Yes.
format has to be consistent, right? Regardless of wherever the chat comes from, be it WhatsApp, Instagram, or
Yes. So what we've seen is, by our understanding, whenever we export the chat, these three columns are always there in the same order, and there may be additional columns also in the CSV, but we've made sure that we ignore those columns.
okay.
So we will primarily work on these three. Like they are the essential columns.
Got it. So let's take WhatsApp as an example. So when you export one single chat on WhatsApp, I think you get a TXT file with like all the messages and timestamps, right? Not a CSV. So like, does your software do the conversion, or how does it work?
That is the scope of improvement for us. We'll make sure that we convert the text file to the CSV file.
Okay. Yeah.
Or we can add a both option where if not just a CSV file upload, we can also
Whatever the user is comfortable with.
Cool. I think I just have one last question. Like, it's a short question, like answer.
Sure. Yeah.
Are you guys like using any external, say for example, LLM or any external processing services?
No, sir. As I initially mentioned, privacy is a key concern for our website, which acts as a differentiating factor. And recently, there have been a lot of issues and court cases regarding data privacy. So we made sure that we use our own machine learning models and not rely on sending data outside to OpenAI or Gemini API files.
Perfect. Got it.
Yeah.
I think that's it from my end. Amishi, do you have any other questions?
No, that's fine.
Cool. Thank you guys so much. It was a nice
Thank you so much.
presentation.
Thank you for your time.
Thank
And
you.
all the
Thank you, sir.
best.
Thank
All
you
the
so much.
best, guys.
Thank you.
Thank you.
Can we just leave?
Yeah. You can leave.
Thank you.
Yeah. So we have two teams left. One is Central Park. The first is Central Park, and then we will quickly wrap it up with Code and View. Okay. So who is the team leader?
Yeah, hi, it's me, Ayush.
Yeah. Okay. So instructions for you is that first you present and present the your presentation and try to focus more on the demonstration part. You will
Mm-hmm.
have 7 minutes. And for only since you are the team leader, so you speak and demonstrate everything, or you can decide anyone else to do it. After the
Mm-hmm.
presentation ends, you all can answer the follow-up questions which will be asked by our judges. Is that clear?
Okay, got it, got it.
Okay, sure. You can start.
So it's like basically 7 minutes of both presentation and demonstration,
Yeah,
or
yeah, you
is it
have
like
to
seven
manage
for
your
each?
time in that way because we have 7 minutes for both the presentation and the demonstration, so you see accordingly.
Okay, okay, okay. Just a sec. Yeah, yeah. So is my screen visible? Yeah, hi. So good afternoon, everyone. And our project's name is basically KETA, which is the short form for Keep in Touch AI, which is, somewhat related to the current problem statement which we are going to address. And moving on to defining the problem statement. So what we can see is that social drift in the current Gen Z world is consists of basically delayed replies, which is that you have lots of chats and multiple conversations are just piled up and you don't reply. Maybe you are not in the mood. Maybe you have a hectic timetable, so you are not able to reply to everyone. And maybe in those chats there are buried plans which were planned long ago, and now it seems like you're ghosting them. And this can also cause relationship weakening and forgotten follow-ups, maybe because if you ask something and then you just didn't follow up on it because you forgot. So these are the main things which we are going to target in this project. And if we look at the statistics, so there are 42% of inactive threads overall in social platforms for Gen Z users, and the median response delay growth is growing by 63% over the last 3 months. So the main thing is that we are going to target the lack of intelligent automation to assess the gradual decay which has been going on and how to address it and what priority should you give to whom. So this is the overall system architecture where we first take the raw communication in the form of CSV. We do pre-processing, and then we extract features which are basically feature frequency per week in activity days, average response trend, which just shows that if the overall trend in the given CSV file, like if it's a uptrend or a downtrend, which we also see in stock markets. So if it's a positive slope, it means that the replies are gradually slowing and there is a decay. Whereas if it's a negative slope, then it shows that it's improving. And then there is the engagement slope, which again shows that if it's negative, the slope is negative, it means that there is some kind of cooling that is being detected, which means the conversation is becoming colder and colder over time. Then there is reciprocity, which means that who is taking initiative in given conversations. And so these are basically the crucial features which we have implemented for our model. Then moving on to the next phase, which is health scoring, where we take two metrics, which is the health score and the decay score. So health score is basically a scale on 0 to 100, which just which just classifies basically if the chat is good in a healthy state, if it's becoming cold gradually, if it's on the stage of just being ghosted, or if it's just one sided, if you are just replying and you're not getting response over the given time span. So that's where these two metrics come in. And then moving on to the next phase, we have the state classification phase, where we have multiple states which we use for the decision engine. So the main part here is the decision engine, where we take the state, we take some raw features, and then we decide on that, or like what response and what priority we should be giving to a given conversation. Like the CSV file can contain multiple conversations, so we what a particular person we should be targeting is basically decided in the decision engine. And in the action generator, we calculate what is needed and give the appropriate response, the appropriate message that should be sent to the particular conversation to keep it going, depending on what state it is in. Then this is the basic workflow which is being demonstrated using a graph. So as we can see, in week 1 the conversation was pretty good, it was a stable period. Then gradually after week 3 it started declining, And if we just look at this red line, it's the risk threshold. So we can see that it went below the risk threshold after week 9. So week 10 is where hypothetically the AI model gets triggered, and it sends an email or a reminder to the user that this chat is going below the risk threshold, and if you want to maintain that relationship, you should send this message to this particular user. And once the user takes the appropriate action, that's where the uptrend in the graph can be seen, which is in week 11 and week 12. So again, yeah. Okay, okay, sure. So yeah, yeah, okay. So this is our front end. So we have designed the entire project using Python. So this front end has been developed using Streamlit, and the first page is basically the sign up and login, which is connected to Supabase. So if we just sign in. Yeah. So we get multiple data input options, which is WhatsApp export, conversational log CSV, which is the synthetic CSV which we have used currently. Then you can also use email logs and export it, and SMS export as well. So for the timing, I have this ready with me. Just a moment. So if we just put this data here. So it gives an instant response, which is basically it recognizes the conversations, which is here in this case Aman, Rahul, and Neha and Priya. So it analyzes the conversations, and basis on the basis of that, it gives us the uh, important matrix for the layman people, which is the last interaction and the priority in which we should be texting them and what we should text and the overall status and strategy. And then we have this copy message as well, which the user can just copy to the clipboard and send it to them. So these are the basic outputs in the layman terms. And then if they want the actual scores, so here is the scores which our model has predicted. So health score for this person is 59 out of 100, which means that it's in the medium phase, and the decay risk is 0.1 out of 1. So there's not much decay. So we have such data available as well. And yeah. So yeah, yeah, that's it. Yeah. Sure, I'll just stop my screen share.
Yeah. Firstly, good job presenting, guys. Uh,
Yeah.
I will start with the question. So you mentioned you have CSV and TXT file, like uploads.
Input options.
Yeah, correct.
Yeah.
So do you also convert? So I'm assuming you might need it in a particular format, right? Say, for example, if it's CSV, you might be reading
Mhm.
some particular column headings or
Columns.
something like
Yeah,
that, right?
yeah.
Yeah.
Mhm.
So you have different options available like email, SMS, WhatsApp. So how do you handle those different formats of export? Does the user need to convert it to your format, or do you do it automatically?
No, actually, it's basically the user needs to convert it to our format, because we first tried using different formats, and then we decided that let's stick to first the synthetic conversations, which are basically AI generated, and let's train our model on that. So that's why the like for the time being, we are just sticking to CSV formats.
Okay, got it.
Yeah.
Uh, yeah, I think that's it from my end. Amishi, you can take over.
I had one question. Now,
Mhm.
let's suppose if I'm talking about a WhatsApp conversation, right? So everyone has
Okay.
different style of communicating. Like
Yeah.
some people can be using different languages as well, like English or English, let's say for
Hindi. Yeah.
example. Then
Yeah.
there
Yeah.
is Hindi, and then there is emojis and everything being used. So how
Hmm.
is your system tackling all these different communication styles?
Even we thought of the same while deciding on what data we should use for training, because the initial problem was that if we use our data, then it is going to be in English uh, conversations, which was quite tricky. So we didn't go that deeper into that side. So we just use
Okay.
English conversations and emojis as well. And we have a dedicated system, action system basically, which
Hmm.
has all the messages ready. And depending on the priority and the type of state the conversation is in, it's going to give different replies. So for email, there's going to be a more formal or semi-formal approach. For WhatsApp, there's going to be a different approach, which is very informal, can use emojis, etc.
Okay, and like one more, what about the sentiment analysis? Like sometimes like some words are used in one way, but the like in one context, but it's
Hmm.
probably not meaning the same, right? When we talk informally via WhatsApp. So is that
Yeah,
being handled somewhere?
not particularly.
Okay, I sure that. And it was overall, it was like a great presentation. Thank
Thank
you,
you.
guys.
Okay, guys, you can leave the meeting. We will let you know the results.
Sure. Thank you, everyone. Have a good day.
Okay.
Thank you. Bye, bye
Thank
guys.
you.
Okay. So we just have the last team, Code and Brew, left. Just Sean is just quickly add him, and then we will wrap it up.
Hello. Hi, what's up, guys? Yeah. Um. Mm-hmm. Mm-hmm. Okay. Do you want me to share my screen? Okay. Just 1 second. All right. Is my PPT visible to you guys? Yeah. So, some of the logistics might be a little messed up because I'm at the airport. I just landed, so I've tried to put everything together ASAP. So yeah, hi guys, we are Team Code and Brew, and the problem statement that we received was something that could help us turn our chat data and insights and our relationship into something that is long lasting. And with the moving race and with everyone being so busy around all of the different things, so we try to create a pipeline and set up an architecture to make sure that something is built that would actually be used by, let's say, our generation or the future generation. So we have a demo live, as well as I've shared the repository link. So coming to what we saw as a problem in this was, like, there is no system that actually makes sure that if you've responded to messages, there's no sort of reminders, or there's no sort of mechanism in place that helps you remember who you've had conversations with, and keep a track of what connects you make. So for example, you go to a social network, a networking event, you may end up chatting with a lot of people, taking down a lot of business cards, numbers, but somewhere along the lines we aren't actually able to use those connections because there was no communication channel established during the course of that time. So uh, this is just about how these relationships matter and how we've used the metadata and behavioral signals in each relationship to check the frequency, the speed of replies, the conversational depth, as well as the initiation and the reciprocity ratios. Then this is the system architecture. So what we've done is, for this demo especially, we've created a synthetic data set of 10 different people with around 2 weeks or 2 months of conversation history. That's all synthetic, developed by Claude. So we take these raw messages, push them into a pipeline where it is parsed, and it is broken down into tokens and keywords to understand at a basic level what that conversation might be about, also capturing the time of conversation, the uptime, the downtimes, and then after that we've created 12 metrics that are going to score your relationship on the basis of how frequently do you communicate, how fast do people reply, what's the active times, how healthy is your relationship with them. So for the health scorer, we are just using these 12 metrics to calculate a score. I'll show the formula in the next slide. And then we detect a few anomalies that can be maybe you are ghosting someone way too much, or you've just forgotten to stay in touch with them. And then finally we just develop actionable insights that gives you like a queue where you can just select which messages make a lot of sense to you, and what do you want to do with them. So this is an overview of the pipeline that I just explained. Now, yeah, to quantify these relationships, we've taken a few elements. So one is reciprocity, which is basically the balance between exchanges. So for example, how many times you continued a conversation, or how many times your the part that you played in the conversation was moving it forward. Then the frequency, so messages per time window. Then recency, so recent, the last meaningful interaction that you had with them. The rising or declining engagement, so maybe last week you had a lot of conversations but this week you did not. Then the depth of messages, so for example the length of messages, the topics used, the emotional signals, the amount of emojis and stuff like that. And finally the initiation balance, which is who leads the conversation, like who starts it, who initiates it. So on basis of these factors we are doing a classification for 82 to 100% we call it a thriving relationship. For 68 to 81 we call it stable. 50 to 67 we call it kind of cooling. And since these are hearts, this means your relationship might still work out, but 30 to 49 and 0 to 29 means that you need to do a lot of work in order to move forward with this relationship. Then, yeah, there's the smart risk detection that works on all the anomalies. I think I'll just switch to the demo. Just give me 1 second. Um, do you guys want to look at the GitHub repo as well?
No, you
You
can
can
start the
just,
demo.
yeah, start the
Okay.
demo and share the link in the chat maybe.
Hmm.
Okay. So I'll just share the demo link in the chat as well. 1 sec. Yes. Yep. So basically, I try to put together a sort of baseline or like an MVP for how this app could look like. So basically, in the initial phases, we are just trying to connect this with WhatsApp, Instagram, and Discord to fetch all these messages. So here we've taken a synthetic data of around 10 people. I've used Cloud Code for a lot of the backend part and the processing part. And so how many relationships are thriving, how many need attention, and then how many actions are pending. This is just the pipeline for the hackathon rubrics to just be there, that this is how the architecture actually works. So for example, these are the 10 people that we've connected with. So if you go to, for example, the first one, you see the score that you've got, which is 89%. The relationship is thriving. As you click on it, you can just see the metrics, which is the total amount of messages, the reciprocity ratio, the average response time, messages per week, how many were sent, how many were received, initiation ratio, conversation depth, and a weekly message frequency graph. So that this gives you an insight about how many times you guys contacted, and then the recent messages that you guys had. So, for example, if you just want to recall the conversation that you most recently had with the person, irrespective of whatever communication platform you were using, this is a way to find that out. And this is the same case with all of these people. And if you look at, these are all for WhatsApp. So if you look at the Neha Gupta part, so you can see that there's a fading pattern. So your conversations are maybe fading away. You need to interact more. Here you've just activated ghost mode, which is one of the anomalies. There are two missed follow-ups with the question that she's asked and haven't replied to. Then we also give you a relationship trend. So basically all your contacts in one graph, depending upon how many times you've contacted them, how is your score actually being maintained over the course of a month or 12 weeks. And then these are the AI insights that we are trying to bring up based on your conversation history. So you can just see that your most balanced relationship is with Mira Iyer. Yeah, yeah, I've just wrapped it up. So the final thing is just the action queue. So we just provide you insights as well as suggested messages so that you can just uh, open WhatsApp and it links to your account. It can just send a direct message and it drafts up a message for you and you can just mark it done. Yep, that's the whole thing.
Firstly, that was a really good demo. I think it was
Thank
one of
you.
the cleanest uh, demos, like in terms of having all the insights. Like I could understand it within like 2-3 minutes what was going on.
Yeah, agreed.
Uh,
Thank you,
I
guys. I made it on the flight.
That's crazy. Yeah, so I just have one question. I understand
Hmm.
that you are using synthetic data for all of this, right? Considering it's a
Hmm.
hackathon.
Hmm.
Have you explored integrating it with, actually integrating it with WhatsApp and
Yeah, so in order to integrate this with WhatsApp or let's say any platform as such, the easiest future scope that I see is tools like Element or Slack that allow you to export those conversations to, via an API or an endpoint. So if I do plan to continue this, maybe trying it out or experimenting with the enterprise solutions first, and then maybe exploring the WhatsApp and Instagram features because of the end-to-end encryption as well as the privacy laws. It might be a challenge, but it's not impossible to connect it with the right framework and the right technology being used.
perfect? That sounds like a good plan. Yeah, I don't think I have any other questions. Amishi, we can.
I had one scenario, okay? Let's suppose
Mm-hmm.
that there is some user, okay, who naturally texts less, but it's a healthy relationship because that's how the person is. So how will your system handle a situation like that?
So basically, what we are doing is, considering this is a demo, like a few future scopes that we have thought about
Hmm.
are firstly analyzing your patterns. So, for example, if this person is mostly active, let's say on Wednesdays and Thursdays around 5 p.m., so everything is, personalized in a way that the messages and the aggregation and AI insights try to prioritize that, and based on the depth and sentiments of the conversations you have. So, for example, you do text someone once a week, but the depth of conversations or the trends that are being followed come out to be at a very stable score. So that's the way the model just adapts to your personalized texting patterns. I mean, that is something that would have to be constructed even better, looking at how to make it inclusive for all kinds of people and all kinds of texting patterns. But yeah, I think that is something that could be achieved.
Okay. Yeah, I think even I'm good. Great presentation though, loved it.
Thank you, guys. Are we
Yeah,
done?
Yeah,
yeah,
I think that's it from our end. Thank you so much, Divyansh, and all the best.
Thank you.
All the best.
all the best. We will let you know. That's it.
Yep.
Okay. Thank you. Okay, so this ends our final round. Thank you so much, Amishi and Nisar, for judging the event. I really appreciate it. How did you like the presentations and everything?
I think it was really good. Like, given that they had like such less time, like 16 hours, and everyone came up with a prototype, which is challenging to come up to start from zero and at the end of 16 hours to have a prototype. So that was really good. I loved how some of the presentations that actually reached to the level where things were getting automated. So yeah, overall, it was great job by everyone who participated and presented.
Yeah, firstly, thank you again for having us. And yeah, just like Amishi said, like 16 hours is not a lot of time to build anything, to be honest. And tackling such a complex problem statement, I think all the teams have done a really good job. Yeah, I think that's it. I mean, we've been seeing some really interesting points, and yeah, I'm interested to see how these guys take it ahead. So yeah.
Yeah, true.
Yeah, thank you so much once again. So, like we will announce the results shortly after, of course. I will talk to both of you and then we can announce the results. Thank you so
Sure.
Also,
Thank you.
kudos to you guys as well for organizing such a cool event and, like, having opportunities available for students to think more, create more. I mean, we need more of that. Yeah. So
Yeah,
And
definitely.
yeah, and great job with like selecting the problem statement. It was really something unique and something which like more people can build upon because there's really less tools available there. So people can pursue this problem statement ahead also.
Yeah,
So
yeah.
great
Whole
job to
credit
the
goes.
entire team, everyone, even the people
Yeah,
who are
yeah.
like not here right now.
Whole credit goes to these two guys, Shonish and Vivek. They have worked really hard. Like I guess we didn't have the problem statement until last night, but they really did something special for us. And yeah, we had a great event, and also with your presence, it was really nice to have you guys actually.
Thank you guys for having us.
thank you guys.
We're going to end the stream with this. We'll announce the results soon on our Instagram page. Thank you guys for watching.